video, we are going to learn about roasting. Now, when we talk about roasting, what is roasting? Is the oxidation of metal sulfide to give metal oxide and sulfur dioxide. So it's just oxidation. When we talk about oxidation, addition of what? Oxygen, right? Of metal sulfide to give metal oxide. I get it. So let's give some equation here. We have 2ZNS plus O2 and giving you 2Zn metal oxide plus what? Sulfur dioxide S2O2. So it's addition of what? We are having addition of oxygen, and therefore we are trying to separate the sulfide from this mineral and change it to oxide. So we add some moles of oxygen to it, then we change it at the end. The reaction will make us get zinc oxide, and then the sulfur dioxide is what? Evaporated, or is in, because this is a gas, and then we concentrate on the zinc what? Oxide for further extraction. Now let's note that with roasting, the temperature that the range of temperature that roasting takes place is 900 degrees to 1000 degrees. That is for roasting, right? Now that is it. And with roasting, we have some source of thermal energy for roasting. So let's look at sources of thermal energy for roasting, because before we can roast, we need some source of thermal energy. And the first one is heat of reaction. We have heat of reaction. So with heat of reaction, when sulfur changes to sulfur dioxide, we have that the heat of reaction becomes negative 0.940 kilocalories per kilogram mole. So when we have several oxidation reactions, such as the iron changing to hematite, and in this case it releases iron sulfide, which also releases some thermal energy, right? Yes. So one source of heat for roasting is what? Heat of what? Reaction. It can generate its heat by itself due to the chemical reaction, right? So in this case, we have some calculation for heat of formation. So let's do some calculation for heat of formation. So let's do some calculations. And in this case, this calculation is on heat of formation. So in that case, we having after you've done your oxidation reaction, which is, let's take one example. We have CuS plus 2O2 giving you 2CuO plus SO2. We are supposed to find the heat of formation in this reaction. And for the heat of formation, we know that the formula for finding the heat of formation is change of heat of formation is equal to the summation of what? Heat of formation of the product minus the summation of heat of formation of what? The reactant. So in that case, in a given question, they are going to give us the heat of formation for each of these compounds or gases, right? So for us to calculate this, in a table, they'll give you a table which consists of various heat of formation. So we have a table. So let's try finding the heat of formation for this. We have it to be HFO, HF heat of formation, change of heat of formation, and we have this to be the product. And when you look on the table with calcium oxide, we have calcium oxide to be 2 bracket open negative 38500, and we have plus negative 296.836 from the table, which is the sulfur here, dioxide, then minus the reactant here is copper sulfide. We have it to be negative 18950, and then plus oxygen here is a gas, it becomes 0, then you close. Then you do your calculation, which is 2 into bracket negative 28500, yeah, 28500, and you close it, plus you do negative 296.36, then you close it, minus bracket open negative 18950, and in that, at the end, what you are going to get is you are going to have the heat of formation to be negative 583. You're going to have it to be, sorry, you're going to have it negative 58346.36, and the unit is kilocalorie per kilogram mole. Now, the reason why we are adding the to it is that you add the number of mole, right? So if you first you check if a question is given to you for you to find the heat of formation, you check if the equation is what? Balanced. So the first thing you must know is that check that the equation is balanced, and then individual heat of formation will be given to you. The formula you're going to use is the heat of formation of the product. That's the summation of the heat of formation of the product minus the summation of heat of formation of the what? The reactant, right? So in that case, we did it very simple. So because here we have 2 and bracket open, because we have 2 copper oxide, 2 copper oxide, and with 2 copper oxide, the copper oxide, the heat of formation is negative 38500 kilocalorie per kilogram mole, and then you do your summation, then you have this as your heat of formation. So this is how we can calculate the heat of formation. Let's do one example with that. Let's find the heat of formation for this reaction. So for heat of formation of this reaction, we have this reaction to be zinc sulfide reacting with oxygen gas, giving you zinc oxide plus sulfur dioxide. So in that case, let's do some balancing here. This will be 1.5 here. So we have this balance. How do you find the heat of formation here? We know that the heat of formation is equal to the summation of heat of formation of the product minus the summation of heat of formation of the reactant, right? So in that case, this is the product. So we have it to this. They will give us their various value, right? And in that case, when you are doing it from the table, you get to know that the summation of that will be, let's do it, that will be zinc oxide, which is plus SO2 with their heat of formation minus zinc sulfide plus 1.50. I know that with oxygen gas, I know that the heat of formation is 0. Then you calculate. So they'll give you the values for this and just put it inside. And please never forget the unit, which is kilocalorie per kilogram mole. Never forget the unit. Thank you very much for watching this video.